In 6 months,
Southern Europe experienced two catastrophes that should never happen in sequence. Summer 2025, Spain and Portugal burned 640,000 hectares. Winter 2026, Italy's massive cliff collapsed under the rain. Over 1,000 people evacuated. Southern Europe didn't just have bad weather, it had two opposite climate extremes separated by 180 days. And the reason why reveals something critical about how weather itself is changing. Here's exactly what happened. Summer 2025, Spain recorded a heat wave lasting 16 consecutive days, the hottest stretch since records began in 1850, 4.6 degrees Celsius above average. 380,000 hectares burned. That's larger than Luxembourg. Portugal lost 260,000 hectares, 3% of their entire country. 36,000 people evacuated. Italy recorded 4,597 heat deaths, the highest total any European country has ever recorded in a single year. Winter 2026. By January, everything reversed. Storm Kristin hit Portugal as the strongest storm ever recorded in the country. 208 kilometers per hour wind gusts, 167,000 homes without power. Then, Cyclone Harry crossed the Mediterranean and dropped 500 millimeters of rain on Sicily in just 72 hours. That's a year's worth of rain in 3 days. In Nishemi, a 4-kilometer cliff face collapsed. 1,500 people evacuated. €1 billion in damages. The paradox. Sicily was in the worst water crisis in its history. Then it received more water than it normally gets in months, delivered as a catastrophe. How does that happen? The answer begins about 10 kilometers up in the atmosphere, with something called the jet stream. The jet stream is a river of fast-moving air that circles the Earth. Normally, it directs weather systems across the northern parts of Europe. That's why Northern Europe has changeable, often stormy weather. But in winter 2025 to 2026, something unusual happened. The jet stream meandered unusually far south. Instead of directing storms across Northern Europe, it started steering them directly over the Mediterranean, over Portugal, over Spain, over Italy. And here's where it gets critical. The Mediterranean Sea in January isn't cold. It's 2 degrees Celsius warmer than its historical average. When a storm system crosses over warm water, it doesn't weaken, it strengthens. Warm ocean water evaporates moisture continuously. That moisture-laden air feeds approaching storms. Instead of storms weakening as they move inland, as they normally do, these storms were getting stronger over the Mediterranean, then hitting the coast at peak intensity. Storm Kristin, Cyclone Harry. These weren't anomalies. They were the predictable result of two factors combining: the jet stream in the wrong place and the Mediterranean being warmer than normal. But that still doesn't fully explain the magnitude of what happened. To understand why these floods were so destructive, you need to understand what the summer wildfires did to the land itself. When a wildfire burns through an area, it fundamentally changes the soil. Wildfire heat, temperatures that can exceed 500 degrees Celsius, alters the chemical structure of the topsoil. It makes it hydrophobic. That means water repellent. Under normal conditions, when rain falls, some of it infiltrates into the soil. The soil acts like a sponge. It holds water, slows runoff, and reduces flooding. But burn soil does the opposite. Rainwater hits the hydrophobic soil and doesn't soak in. Instead, it runs off the surface, fast, down slope, picking up ash, loosened soil, and debris as it goes. Scientists call this a debris flow. Emergency responders call it liquid concrete. And here's the critical timeline. Wildfire-induced erosion doesn't peak in the first year. It gets worse over 5 to 6 years. Portugal burned 260,000 hectares in 2025. Spain burned 380,000 hectares. That's 640,000 hectares of hydrophobic, erosion-vulnerable soil spread across 2 countries. In January 2026, just months after those fires, winter rains arrived. Those rains hit burn scars that were still fresh, still unstable, still at maximum vulnerability. The cliff collapse in Nishemi? That wasn't random. That was the predictable result of soil erosion destabilizing coastal geology. The heavy rainfall from Cyclone Harry saturated the cliff face, adding weight and hydraulic pressure until the soil simply gave way. Now you might ask, couldn't this have happened without climate change? Technically, yes. Jet streams meander, storms occur. Even burn scars can cause flooding. But here's what climate scientists have discovered through a process called attribution science. When researchers compared the meteorological conditions that caused Cyclone Harry to the historical record, they found something striking. Storms with similar atmospheric conditions occur in the current climate, 1.2 degrees Celsius warmer than pre-industrial, with significantly different characteristics. The winds are 4 to 8 kilometers per hour stronger. That's a 15% increase in wind speed. The rainfall is 14 millimeters per day heavier. That's a 10% increase in precipitation. The atmosphere itself is up to 5 degrees Celsius warmer than comparable storm events from past decades. What does that mean practically? It means Cyclone Harry, in a cooler atmosphere, would have been a significant storm, but not the catastrophic event it became. The rainfall would have been intense, but not 500 millimeters in 3 days. The cliff wouldn't have collapsed. Climate change didn't create the paradox, but it intensified it. It made the swings more extreme. And there's another layer, the Mediterranean water itself. The Mediterranean is warming faster than the global ocean average. In January 2026, it was 2 degrees warmer than normal, which means when winter storms arrived, they found an unusually energetic ocean surface to feed on.
Now here's where the paradox takes an unexpected turn.
In one sense, the winter floods were catastrophic. Over €1 billion in damages, people evacuated, infrastructure destroyed. But in another sense, they solved a problem that seemed unsolvable weeks earlier. Before Cyclone Harry, Sicily's water crisis was dire. Reservoirs were critically low. Water rationing was severe. The flooding from Cyclone Harry was destructive, but it replenished reservoirs across Spain and Italy to levels not seen in years. Spain's water reserves climbed to 57.2% capacity. In Catalonia's internal basins, levels reached nearly 85%, effectively ending the drought emergency in those regions. This reveals something crucial about adaptation. Sometimes the problem isn't the lack of water or the intensity of storms. It's timing and preparation. Italy's early warning system did allow 1,500 people to evacuate Nishemi before the cliff collapsed. That's adaptation working. And there are emerging solutions. Jet stream forecasting is improving. Scientists can now predict these unusual southern meanders 2 to 3 weeks in advance. Burn scar restoration programs Planting vegetation, placing erosion barriers, can reduce soil loss by up to 50% over the critical 5 to 6 year window after fires. Reservoir management built around paradox events, understanding that you'll get swings between extremes, can turn destructive floods into resource opportunities. The paradox of Southern Europe in 2025 to 2026 reveals something essential about climate change. It's not just making things hotter or wetter, it's making weather itself more extreme and unpredictable. It's creating new combinations of extremes, summer heat so intense that it dries entire regions, followed by winter storms so powerful that they destroy the very landscape that was just burning. And it's doing this faster than our infrastructure can adapt. But, and I want to emphasize this, understanding the paradox is the first step to managing it, and adaptation is still possible. We can predict jet stream meanders. We can design flood defenses that account for burn scars. We can restore vegetation to stabilize hillsides. We can manage reservoirs to capture extreme rainfall instead of letting it cause disasters. What we cannot do is wish the paradox away or expect it to stop on its own. As long as the Mediterranean keeps warming, jet stream patterns remain unstable and burn scars remain vulnerable. These extreme swings between heat and flooding will continue, and they'll likely get more intense. The description below has resources on Mediterranean storm forecasting, burn scar management, and how early warning systems saved lives in Sicily. That's your research starting point. If you want to understand the climate tipping points happening right now, the hidden mechanics that are reshaping how weather works across the entire planet, subscribe to The Green Blueprint and follow us on Instagram at @thegreenblueprint_TGB. Let's explore our Earth Climate Frontline. Each episode breaks down a different climate paradox, explains the science, and shows what real adaptation could look like. Not doomsday rhetoric, not greenwashing, just the honest climate mechanics you need to understand our planet. And if you haven't watched our latest episode yet, The New War on the Arctic, Shipping, Soldiers, and Silence, go watch that next. It goes deeper into geopolitical instability driven by climate change. It connects. Thanks for watching. I'll see you next week at The Green Blueprint. Stay green, stay healthy, stay informed.